Hey, science enthusiasts! Today I'm diving into the heart of matter itself, exploring what's inside an atom. Imagine this, the entire universe, with all its galaxies and stars, scaled down to something so tiny, it's almost invisible. That's an atom for you. Now let's break it down. At the core of every atom, you'll find the nucleus. This is where protons and neutrons hang out. Protons have a positive charge, while neutrons are neutral. Think of them as the sun in our solar system, holding everything together with their gravitational pull. Surrounding the nucleus are electrons. These tiny, negatively charged particles zip around in what we call electron clouds. They're not fixed in place like planets. Instead, they exist in a state of probability, making them a bit tricky to pin down. So why don't the positively charged protons in the nucleus repel each other? That's where the strong nuclear force comes in. This powerful force keeps the protons and neutrons tightly bound together, defying the repulsive electromagnetic force between the protons. The space between the nucleus and the electrons? Mostly empty. In fact, if the nucleus were the size of a football, the electrons would be like tiny grains of sand in a stadium. This vast emptiness is one of the most puzzling aspects of atomic structure. But it's not just empty space. Within this space there's a dance of energy and particles, a realm governed by the strange rules of quantum mechanics. Particles can pop in and out of existence, and electrons can teleport from one orbit to another without traversing the space between. Mind-bending, isn't it? Atoms come together to form molecules, which in turn build up everything around us, from the air we breathe to the screen you're watching right now. The interactions between atoms, governed by their inner structure, determine the properties of matter. Ever heard of isotopes? They're atoms of the same element with different numbers of neutrons. This little difference can make some isotopes stable, and others radioactive. For instance, carbon-12 is stable, while carbon-14 is radioactive and used in carbon dating. And what about ions? When atoms gain or lose electrons, they become ions. This change imparts them with a charge, making them crucial in conducting electricity and forming compounds. Understanding atoms isn't just for scientists in labs, it's fundamental to grasping the world around us and the technology we use every day. From the food we eat to the devices we hold, it all boils down to the behavior of atoms. Fascinating, right? So next time you look at anything, remember it's all made up of countless tiny universes, each an atom with its own intricate and mesmerizing structure. Thanks for exploring the inside of an atom with me today. Until next time, stay curious.